Here we go. All right. Okay, number one here, 1A. All right, you have cosine and then tangent plus cotangent equals cosecant. Let me make sure I have my notes and make sure I don't forget anything. All right, so for this one is cosine x and then convert it to sine x over cosine x plus cosine x over sine x. All right. Then once we do this, we distribute, right? And what do we get? We get cosine x, sine x, all over cosine x, plus cosine squared x over sine x, right? So from this, you could cancel out the cosine x's here. You get sine x plus cosine squared x over sine x. And then what do? You get a common denominator here. So you get a sine x over sine x. So that's going to be sine squared x plus cosine squared x all over sine x. So there's a little bit of a delay, sorry. And cosine squared x plus sine squared x plus cosine squared x is 1. So this equals 1 over sine x, which is then equal to cosecant x. All right. Number 2, all right, you have sine x plus pi over cosine x plus 3 pi over 2 is equal to tangent squared x minus secant squared x. What's your problem here? You're going to use the sum property. So this is I'm going to use a sine a plus b is equal to sine x cosine b, sorry, sine a cosine b plus cosine a sine b. That's the formula I'm using. And then the cosine a plus b is equal to cosine a cosine b minus sine a sine b. Okay, so these are the two formulas I'm using. So I could get to the tangent squared minus secant squared, right? So if I use this right here, this is sine a is x cosine pi plus cosine x sine pi all over cosine x cosine pi plus or minus sine x. Huh? Oh, that's right. 3 pi over 2. My bad. Thank you. I was in my zone. 3 pi over 2. And then sine x sine 3 pi over 2. Thank you. So cosine pi, this is equal to -1. right? If you use a unit circle, sine pi is 0, right? Cosine 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. Okay. So this is -1 times sine x, which is negative sine x. This is 0, right? Because 0 times cosine x will be 0. Over, this is 0 right here. Cosine x times 0 is 0. Negative sine x times -1 is positive sine x. That equals -1, right? Now, what does tangent squared minus secant squared equal to? That's also equal to -1. And since they both equal to -1, you're good to go, right? Cool. Right. Number 3.
Question really quick.
Yeah.
How come on top it's cosine pi instead of cosine 3 pi 2?
Because this is the pi right here. That's the b. For the top,
Gotcha.
right? This is the b. For the bottom, this is the b. Cool.
Got it. Okay.
All right. So number 2, we have the cotangent of x minus 1 over the cotangent of x plus 1 equals 1 minus tangent x over 1 plus tangent x. So as I was explaining before, what they did was they divided the top and the bottom by cotangent x. So they divided the cotangent x over cotangent x minus 1 over cotangent x, all over cotangent x over cotangent x plus 1 over cotangent x. By dividing both the top and the bottom by cotangent x, you get, this is 1, right? Minus, this is tangent, right? Because 1 over and then cosine over sine, you flip, you just get the reciprocal of that, right? So that would be tangent x over 1 plus tangent x. And that is your answer. All right. Cool. All right, so all right, so for number 3, you get cosecant theta plus cotangent theta equals sine theta over 1 minus cosine theta. This one you kind of have to work both sides so they kind of equal each other. All right, you kind of have to balance this out here. So let's start on the left here. This is 1 over sine theta plus cosine theta over sine theta. So this ends up equaling 1 plus cosine theta over sine theta. Cool. And then now we look at this side here, and we're going to multiply the top and bottom by 1 plus the conjugate cosine theta, 1 plus cosine theta. This equals sine theta Yeah, sine theta plus sine theta cosine theta all over, this is 1, if you multiply by this conjugate, minus cosine squared theta. You see that? Because if you multiply the FOIL, 1 times 1 is 1, 1 times plus cosine minus cosine, will eliminate that, and then minus cosine theta times cosine theta is cosine squared theta. This then is equal to sine squared theta, right? So it'll be sine theta plus sine theta cosine theta all over sine squared theta. I factor out the sine. Once I factor out the sine theta, it's 1 plus cosine theta over sine squared theta, right? What do I do next? What do I do that? What do I do next? I could cancel out the sine thetas. So it'll be 1 plus cosine theta over sine theta, and this equal each other.
Oh.
What? Cool. Any question on that? Number 4 is the half angles one, where you're using the cosine, I guess, b over 2 is equal to plus or minus the square roots of 1 plus cosine b over 2. And notice that you know how it says pi is between, or b is, beta is in between pi and 3 pi over 2. That means that what the cosine is going to be negative, right? So if the cosine is going to be negative, you're going to use this portion of the plus or minus, okay? And you're going to plug in the negative 3 over 2, correct? Oh, sorry, negative 12 over 13 in for the cosine b. The cosine b is negative 12 over 13, so this is not too bad. This is 1 plus negative 12 over 13 all over 2. Right? So then this equals, this is what, 13 over 13 minus 12 over 13. All right. So this equals 1 over 13. Over 2. Right. So that equals 1 over 26, the square root of 1 over 26. So if you do that, this is the square root of 1 over the square root of 26. Can have a denominator of, so it'd be 1 over radical 26, rationalize it. So it'd be what? Radical 26 over 26.
Can you go back up to like the video?
Yeah. Let me double check that.
Like, okay. Essentially.
Yeah. Yeah. Because 13 minus 12, right? Which is 1. So then you multiply by its reciprocal, right? So that's why it's 1 over 26. No, if you multiply it by 2, then it'd be 2 over 13. But since you're dividing by 2, it's 1 over 26. Cool. Cool. This makes me nervous too. So Don't make me, don't ask questions like that, Katie, and you're not in my class, all right, so.
We all get a bad grade.
Huh?
Heard it. Okay.
Yeah, I didn't get a bad grade, you know? it's-
No, you should
whatever.
rip it. I say we all get.
Cause I remember last year you did something where we all did.
Yeah, you guys all got good grades.
So
you know,
like-
I know. All right.
We're talking about like
Yeah.
next, why don't we do? a
This is all on video record, by the way, so you know, you guys are recording it. So I wanna,
I'm trying to compare.
all right, last one, here we go.
So
Last one,
you decide to,
almost, go ahead.
you decide to use -12 or 13 because that's.
Well, the cosine B was -12/13, right? But the reason why I use the minus instead of the plus is because in that bracket I gave you, you know, it says right there, it says pi is less than B is less than 3 pi/2. And notice that the cosine has to be negative, so that's why you use the minus on that one. Okay, that's all. Because cosine from pi being in between. I'm sorry, for the beta being in between pi and 3 pi/2, if you look at the unit circle, right? That cosine it's quadrant 3, right? So the cosine is negative. That's why you're using the minus sign on that.
Oh.
That's all. No biggie. If you don't get that right, that's fine. I think just if you just put that in, if you use this formula, you're good. Okay.
Okay.
All right. If you put plus or minus, you're fine. All right. And last one is you're using the sum product right there, or sum identity of sine. So it'll be sine 3 pi/4 plus 5 pi/6. Remember, you're using this sine A plus B is equal to sine A cosine B plus cosine A sine B. Okay. You plug this in, it'd be sine 3 pi/4 cosine 5 pi/6 plus cosine 3 pi/4 sine 5 pi/6. Man, this has a big delay, right? All right, so now what's the sign of 3 pi/4? That is radical 2/2. Cosine 5 pi/6 is the x value, so it'd be negative radical 3/2 plus cosine 3 pi/4 x value, it would be negative radical 2/2, right? Sine 5 pi/6 pi 5 pi/6 1/2 plus of 1/2. Yeah, okay. So this is what? Negative radical 6/2 plus negative radical 2. Sorry, this is radical 4, my bad. I thought I was adding. Plus radical 2/4, negative radical 2/4. This just equals negative radical 6 minus radical 2/4. That's your answer. So that one shouldn't be too bad. Good. Okay.
We
Cool.
use the pre-assessments on the test. It's also really hard when you-
All right. All right.